many of you have heard of the Drake equation? A few hands, maybe. It's actually the most honest thing that physicists have come up with regarding this question. A fellow named Frank Drake, back in 1961, he said to himself, "What do I need to know to figure out how many aliens might be broadcasting radio signals that we could detect?" And he didn't just guess. He wrote down all the factors, every single one of them, and he said, if you multiply all these together, you get a number that tells you something real about the universe. Now here's the beautiful thing about the Drake equation, and also here's the problem. It's completely honest about what we don't know. Most of the terms in that equation, we basically have no idea what the values are. We're guessing. Let me break down what I mean. The equation has 7 terms. 7. And the first one, the rate at which stars form in our galaxy. We actually know that one pretty well. We've measured it. So that's good. But then it gets tricky. The second term asks, what fraction of stars have planetary systems? Well, we used to have no idea. We thought, maybe some stars have planets, maybe none do. But thanks to telescopes in the last couple decades, we've actually learned something real here. Most stars seem to have planets. That's surprising. We have thousands of exoplanets now. So that term, we can estimate with some confidence. It's probably somewhere between 30 and 100%. That's much better than we could do before. Next comes the question, how many of those planets in each solar system could support life? Well, you need the right distance from the star. Not too hot, not too cold. You need an atmosphere. You probably need liquid water. The estimates vary wildly. Could be 1 planet per system, could be 10. Nobody really knows. We're using our one example, Earth, to guess about 1 billion other planets. But here's where it gets really interesting. The fourth term asks, what fraction of those habitable planets actually produce life? This is where things break down. We have one example of life. 1, the Earth. And from this single example, we're supposed to estimate the probability across the entire universe? That's not science. That's just guessing and calling it science. The truth is, we don't know if life is incredibly common or incredibly rare. And then the fifth term, of planets with life. What fraction develop intelligent life? Again, one example. We don't know if intelligence is common or if it's 1 billion to 1 accident. When you really think about it, and I mean really think about it, not just imagine it, you realize that intelligence as we know it came from very specific circumstances. You needed single-celled organisms. You needed multicellular organisms. You needed things to happen in a particular sequence. Were any of those steps inevitable? Probably not. Any one of them could have been a dead end. And then the sixth term, of civilizations with intelligence. What fraction developed technology that broadcasts detectable signals? This is important. Maybe intelligence doesn't lead to technology. Maybe technology doesn't last long. Maybe technological species go through a phase where they broadcast, and then they stop, or they destroy themselves, or they figure out better ways to communicate that we can't detect. And finally, the seventh term, L. How long do these civilizations actually broadcast for? And this is where the whole thing gets sobering. Because if civilizations tend to destroy themselves after a short time, if the average lifetime of a technological civilization is, say, 100 years or 1,000 years, then the numbers change dramatically. The entire calculation becomes, we are almost certainly alone. Let me show you what I mean. If you put in the most optimistic numbers, the ones that would make an astronomer happy, you get numbers suggesting millions of civilizations. But if you put in more conservative numbers, and by conservative, I mean numbers that are actually justified by what we observe, you get something completely different. You get fractions, decimals, numbers like 0.00000000000001, which means, statistically, there is less than 1 detectable civilization in our entire galaxy. Not the universe, just our galaxy. Now, I realize this is a bit abstract, so let me think about it differently. Imagine I gave you a bucket and I said, go down to the ocean and scoop up some water. Now tell me if there are fish in the ocean. You scoop your bucket, you look, you see no fish, and you say, the ocean must be empty of fish. Does that sound right to you? It's exactly what we're doing with the search for extraterrestrial life. We're looking at an incredibly tiny part of space with incredibly primitive telescopes for just 60 years or so, and we're making conclusions about whether the entire universe is empty. Actually, let me reconsider that. There's something else that troubles me even more than just the statistics. There's something called the Fermi paradox, and it's been bothering physicists since 1950. A fellow named Enrico Fermi was sitting down to lunch with some colleagues, and they were talking about how there must be aliens out there. And Fermi, he just asked a simple question: where is everybody? And I love this question because it's so simple, but it's so profound. Here's the reasoning. If there are millions of civilizations out there, some of them must have had a head start on us. Some of them must have had technology for millions of years. With a few million years of a head start, they could colonize the entire galaxy. Our galaxy is 100,000 light years across. True. But if a civilization had just 1% of the speed of light for their spacecraft, they could colonize the entire galaxy in a few million years. The galaxy is 13 billion years old. A few million years is nothing. It's a rounding error. So if there are all these civilizations out there, why haven't they shown up here? Why haven't we detected any signals? Why don't we see any huge structures or megastructures or evidence of their engineering projects? The Fermi paradox is usually presented as this weird mystery, but I think the simplest explanation is actually just that there aren't very many of them. Maybe there aren't any at all. Now, you might object. You might say, well, maybe they don't want to contact us. Maybe they're hiding. And sure, that's possible. But that's starting to sound an awful lot like we're explaining away the data. We're explaining away the silence. Whenever you have to invoke exotic explanations for why we don't see something, you should start to wonder if the simpler explanation might be correct. Maybe we don't see it because it's not there. I'm reminded of something I used to tell my students. If you're going to believe something, you have to be willing to look for evidence that contradicts you. You have to actually try to prove yourself wrong. And when it comes to extraterrestrial life, we're not doing that. We're assuming it exists and looking for reasons why we haven't found it yet. That's backwards. That's not how science works. So let me ask you a different question. What are we actually looking for? When people talk about aliens, what do they mean? Do they mean bacteria? Microbes floating in the clouds of Venus? That's possible. Life could be incredibly common, and we might never find it. But that's not what captures people's imaginations, is it? No, people think about intelligent life, civilizations, beings who can communicate, and that's where the odds get very, very bad. Because here's another thing that troubles me. We assume that if intelligence arises, it will be like us. We assume intelligence will lead to technology. But maybe that's wrong. Maybe intelligence evolved on some other world, but it didn't develop tools. Maybe it didn't develop technology. Maybe it was content to exist without industry and civilization. We think intelligence is the rarest, most valuable thing in the universe, but maybe it's actually a dead end. Maybe every intelligent species eventually figures out that technology destroys their world and they give it up. Or here's another thought. Maybe technology is possible, but it's self-limiting. Maybe civilizations get technology, and the technology allows them to destroy themselves, and almost all of them do. Maybe the typical lifetime of a technological civilization is 50 years, or 10 years. Maybe in the history of the galaxy, there have been thousands of civilizations with radio technology, but they all destroyed themselves before they could spread across space. That's not a happy thought, but it's a possible thought, and we can't rule it out. The universe doesn't owe us optimism. It doesn't owe us company. And when we look at what we actually observe, which is silence, complete and total silence, maybe we should take that seriously. Maybe we should consider the possibility that the silence is telling us something true. Now, I know what you're thinking. You're thinking about UFOs. You're thinking about reports of aliens. You're thinking about stories people tell. And yes, people do report strange things. People do see things they can't explain. But here's the thing. The fact that you can't explain something doesn't make it an alien spacecraft. That's what I call the argument from ignorance. I don't know what that is. Therefore, it must be aliens. But that's not how you should think. If you don't know what something is, that's exactly when you should be most careful about what you claim it is. When someone tells me they saw a UFO, I believe them. They saw something. But unidentified flying object doesn't mean alien spacecraft. It means they couldn't identify it. Maybe it was weather balloon. Maybe it was a classified military project. Maybe it was a misidentification of a natural phenomenon. Maybe it was a hallucination. All of those are more likely than visitors from another solar system. That's not being closed-minded. That's being rational about probability. And the Roswell incident, which everyone talks about, well, the government did eventually release a report about it. It wasn't an alien spacecraft. It was from a project called Mogul, a classified military program. And people said, the government is lying. They're covering it up. But here's the thing. If the government really had aliens, why would they bother covering it up just to tell us it's a military project? That makes no sense. What makes sense is that it actually was a military project, and now people assume it's aliens. I think part of the problem is that we're emotionally attached to the idea of aliens. We want them to be real. There's something lonely about the idea that we might be alone in the universe. So we see what we want to see. We interpret ambiguous evidence as supporting what we hope is true. And that's human nature, but it's not scientific thinking. You know what I find interesting? The people who are most certain that aliens are visiting Earth right now are the ones who have the least patience for uncertainty. They want definitive answers. They want to know. But science is uncomfortable with that. Science sits with uncertainty. Science says, here's what we know, here's what we don't know, and here's what we can't know. And the truth about aliens is we're in the don't know category for most of it. But let me tell you what would actually convince me. What would actually be evidence? If we discovered life somewhere else in the solar system, say on Mars, or on one of Jupiter's moons, that would be huge. That would tell us something important. It would mean life might be common. But we haven't found that. We've looked. We've sent rovers and landers. We haven't found it. Or if we detected an actual signal, not a weird, unexplained signal that we can't reproduce, but an actual pattern of information from space that couldn't be produced by natural processes, that would be evidence. We've set up systems to listen. SETI, the search for extraterrestrial intelligence, has been looking for decades, and they found nothing that they can confirm. Nothing. Or if we found evidence of a visit, an artifact, something left behind, something that couldn't be explained by any natural process and couldn't be explained by human activity, that would be real evidence. We haven't found that either. So here's my point. I'm not saying aliens don't exist. The universe is vastly larger than anything we can imagine. Mathematically, it would be strange if we were truly the only conscious beings in all of existence. But believing that aliens exist and believing that they visited us, or that they're contacting us, or that they're hiding from us, those are different things. The math says they might exist out there somewhere, but the math also says they're probably very far away, and probably very different from us, and probably living in an era of the universe completely removed from our own. And our belief in aliens, our popular culture, our excitement about UFOs and alien visitors, that's not based on evidence. It's based on hope. It's based on our desire for connection. And those are human things. They're not scientific things. And I think we should be honest about the difference. One last thought, and I want you to really think about this. The universe doesn't care if we understand it. The truth is true whether we like it or not. And the truth, as far as we can tell, is that we're looking at an enormous universe and finding nothing but silence. Maybe that silence is because there's no one out there. Maybe it's because the distances are too vast. Maybe it's because civilizations don't last long enough to meet each other. Maybe it's because life is incredibly rare. Or maybe it's for some reason we haven't even thought of yet. But the point is this: we should look at the actual data. We should think about the actual numbers. And when we do that, we find that having a strong belief in aliens is not well justified. It might be true anyway. Lots of things are true without us having good evidence for them. But we can't claim to have good reasons to believe. And if we can't be honest about what the evidence actually says, then we're not being scientific. We're just being hopeful. And hope is not a substitute for evidence. So maybe you go home and you look up at the stars tonight, and instead of wondering if anyone is out there, you think about what we actually know. You think about how vast and empty and silent the universe is. And you think about how rare and precious life is, even if it's just here on Earth, even if it's just us. Because maybe the most important question isn't, are we alone? Maybe the most important question is, what does it mean if we are? And what are we going to do about it?